Okay, let's look at the idea of addition reactions, and this is basically the heart of alkenes. So if I were to write the general equation for this, it's going to look something like this. Okay, and as you have guessed, this is an ethene molecule, so I'll write that as well. And it's going to react with some sort of reactant. For now, I can call that reactant this, X bonded to a Y. This is going to be a complete molecule. Okay, this double bond here is going to get broken when this reacts here. Okay, so this double bond is going to get broken, and at the product side, you're going to have something like this. This double bond now becomes a single bond, and this X and Y molecule gets attached here. Okay, they get attached here. And now this product is an alkene. Why? Because it has all the single bonds. Okay. By the way, we cannot predict right now if this is an alkene or not, because you can have probably a chlorine here as well. But since I already know what the product is going to be for the first reaction, that's why I say it's going to be an alkene. But generally, it's better not to write that this is going to be an alkene. Okay, but this is the general idea for all the reactions that we're going to study for alkenes. This is the general equation. Now, if I were to write the first reaction, okay, that reaction is something that we call hydrogenation, and that basically means addition of hydrogen. Okay, addition of hydrogen. And the way this works, the way this thing is going to work is that, let's say, I'll just call this down. Okay. Yeah. Okay. So when we study addition of hydrogen, again, we'll take ethene. Let's start with ethene. We'll take ethene, and now ethene is going to react with hydrogen. Okay, as you have seen, it's going to react with hydrogen, and it's going to form an ethane molecule, which is an alkene. So the idea is you're starting from an alkene. Okay, you're reacting hydrogen, and you're forming an alkene. This is the idea of the first reaction. Okay, and how does the reaction proceed? So let's say we start making the equation for this. So this is C2H4. This is not the complete one right now. I'll draw the structured one as well. So again, it's going to be in gases. Hydrogen also is going to be in gaseous state. And the alkene molecule that has been formed, it is also going to be in a gaseous state. So this is C2H6 in gas. Okay, and now if I were to write the structural formula for this, so let's not the formula, okay, the equation. So this is an ethene molecule that we started with. This is an ethene molecule. Okay, and this is in gas. We had hydrogen, so this is the way we write hydrogen. And now you need two things here. You need 150-degree of temperature, and you also need a presence of a catalyst, and that catalyst in this case is nickel, right? So you need 150-degree temperature, you need a nickel catalyst, and what you're going to make? You're going to make an alkane molecule. Now what's going to happen? The same thing that I told you guys. This hydrogen is going to react here. It's going to break the double bond. So the reactant, the product, what is going to be? This is going to be looking something like this. This is how I actually predicted the first one, So this is how the product now looks like. And what has really happened? So this double bond here has broken, and once it has broken into a single bond, now what happens is that here one carbon we know can make 4 bonds, right? Here the carbon had made 4 bonds. But once this bond was broken, once this double bond was broken, now it only had these 3 bonds. So at this place, because it needed to cover the 4th bond, this hydrogen gets attached. And the same goes for this carbon, because after the double bond was broken, it has 1, 2, 3 bonds here, and the 4th one, this is where this hydrogen gets attached. So this is a reaction, and this is how it proceeds. I hope this is clear. Okay, so this is the first reaction. This is something that we call hydrogenation. Okay, and now moving on to the next reaction. This is something that we call bromination. I don't know why my page is going so slow, but yeah, you'll have to bear with me. Okay, let's see bromination. Now bromination, because hydrogenation was addition of hydrogen, the same goes for this. Bromination is addition of bromine. And this can also happen with chlorine. So it can also be chlorination. And that means addition of chlorine. Simple. Okay. And now how does this process go? So you have an alkene molecule. Let's say you have an ethene molecule. Again, that reacts with a Br2. Okay. And that Br2, if I should write this in a proper fashion first, yeah. So this is a bromine molecule. So this is a bromine molecule, and it's going to react to form what? Again, now the double bond gets broken. We're going to get to that as well. But these two Br, the Br molecule, because it exists as it exists as di molecule, so you're going to have 2 bromine atoms. Okay, so now these 2 bromines are going to get attached. So this becomes something that we call 1,2 dibromoethane. Okay, 1,2 dibromoethane. And if I were to write, first I'll write the structure for this. So let's say we talk about ethene. Now the ethene structure looks something like this. And the reactant, which is the bromine, now this is this molecule, and this is going to be in liquid. Okay, this is going to be in gas. The bromine molecule, you need to remember that the bromine exists as liquid at room temperature. Okay, and the way this reaction proceeds is, now this double bond again, this gets broken, so it becomes a carbon-carbon single bond. You have 2 hydrogens at the top. So 2 hydrogens at the top, 2 hydrogens at the center, or at the right and at the left, and then you have these 2 bromines that are going to get attached at the bottom. Okay. They're going to get attached at the bottom. Right? So this makes it 1,2 dibromoethane. Okay, and you just need to remember the naming for this. Okay, you don't need to go in a lot of further detail. Anything else, if needs to be covered, I'll cover that as well. Okay, so if I were to now write the equation for this, so this is C2H4 in gas reacting with bromine in liquid, and that makes it CH2Br. Okay, and this is the first one, CH2 and the Br, and then you have a CH2 and the Br. So this is CH2 and Br, and this is also going to be in liquid. Okay, so this is your second reaction, and this does not need any sort of reactants reagents or any sort of pressure or temperature condition. This is going to proceed the way I just mentioned. So this is your second reaction, and the same way it can also happen with chlorine. What's going to happen? You'll have a chlorine instead of this place, and instead of these bromine, you're going to attach the chlorines, and here you're going to write Cl and the Cl. So that would be something that we call chlorination, and it can also happen with iodine as well. Okay, so these are basically the reactions with halogens, and the halogens are chlorine, bromine, iodine. These guys. Okay, So this is the second reaction. Now, when we talk about the third reaction, this is where it gets interesting, because now you have an alkene molecule. You will react this molecule with water, and it's going to form an alcohol. Okay, and this reaction is called addition of steam. Okay, addition of steam. And other word is called hydration. And this is also basically, steam is also water, right? But this is water in a gaseous state. So what you are doing, you are taking an alkene molecule. Let's say you talk about ethene. You are reacting it with water that is in gas. Okay, this is ethene is also in gas. And what you are making ethanol. Ethanol is from the homologous series. You should recognize that this is an alcohol. And if I were to draw structures for this, let me just quickly draw the structures, and you'll have to bear with me again with this page going ever so slowly. Okay, so if I were to draw the structure now, ethene is something like this. And now the water molecule, how will you write this? You're going to write this way. Okay. Oxygen is bonded to two hydrogens. Okay. So this is how it works. And here, what's going to happen again, this is going to break the double bond. But now the way it gets attached, it's going to be a bit different. How? First, you're going to have the single bond carbon. You're going to place both of these hydrogens like this. Okay, and now at one place, you're going to take this hydrogen, you're going to attach it like this. Okay, and at the other place, you're going to attach both of this. Okay, both of these. How? Like this. Okay, this is how you're going to do it. And you can even interchange it. So the OH can come here and the H can come here. It doesn't matter. And this basically is the functional group of alcohol. This is how you realize it. This is how you recognize the alcohol molecule. So this is how this works. Okay, and this product is also going to be in a gaseous state. And you need a catalyst for this. So for this reaction to happen, so you have C2H4 in gas, which reacts with water or steam. And so you need 300 degrees centigrade of water. Okay, you need an H3PO4 catalyst, H3PO4 catalyst, and you also need 60 atm pressure. Okay, and this basically is phosphoric acid, right? This basically is phosphoric 5 acid. And what you're going to make, you're going to make an alcohol molecule, which you call ethanol, and the reaction, or sorry, the structure equation, or this equation for this is going to be CH3, or not CH3, but the right way to write this equation is C2H5OH, because you want to show the alcohol molecule separately as well. Okay, so C2, then you have got 1, 2, 3, 4, 5 hydrogens and an OH molecule. You're going to treat this as a different separate molecule. Okay, so this is how you write the equation for this. And again, it's going to be in a gaseous state. So these are 3 reactions for alkenes. The one we studied before was combustion, and these are the 3 reactions that, by the way, this part is kind of the part that is mostly tested in your exams as well. Very much tested. And what they're going to say, basically, you have an alkene. They won't say you've got an ethene. They will say you've got an alkene molecule reacting with this. They've got an alkene molecule reacting with that, and stuff like that. And we're going to do that once we move to the past papers, and we're going to cover that part as well. So right now, what I just want to quickly revise is, for the 3 reactions, we're just going to quickly revise what's the status of reactants and products. So for the 3 reactions, For the first reaction, you start off with an ethene molecule and you react it with hydrogen and you make an alkane molecule. And this is going to make things easier for you to remember. And this is in gaseous state, this is in gaseous state, and this is also in a gaseous state. For the second reaction, you start with an ethene molecule, or you can say an alkene molecule. You react it with bromine, chlorine, or iodine, anything. Anyone come. Usually, these two are the most often tested. And usually out of these two, even bromine is the kind of one mostly tested. Okay, so this is going to be in liquid. And then you have, what you're going to make? You're going to make a haloalkane. Okay, you're going to make a haloalkane. Haloalkane means an alkane molecule that is going to have a halogen. And halogen is, of course, Br, Cr, or iodine. This is what we call it. Right? And you need to remember that the bromine exists as liquid at room temperature. So the product here is also going to be a liquid. And it changes with chlorine and with iodine as well. Okay. And now the third reaction, that is, you start off with an ethene molecule, you react it with water, or you can say steam. This is both gas. I forgot the state symbols. Okay. And you end up with an alcohol. That also in a gaseous state. Okay. So this is how this works. Perfect. I hope that's clear. Now we need to do just one more reaction. And I might have made a separate video, but I'm going to cover that in this one. And there is something that we know as addition polymerization. One of the parts, again, very much tested in the paper, and it's very important to cover. So let's move to addition polymerization. And what does this really mean? This is basically a process where, I don't know, I might get the spelling wrong, but I don't care. Whatever. So addition polymerization, this is basically something that you can say is kind of where you have a lot of ethene molecules or a lot of alkene molecules, but we are taking ethene as an example. So you've got a lot of ethene molecules, and these ethene molecules, what we do, we make them react with each other. Okay, so there are certain conditions, which is high pressure and high temperature. At high pressure and high temperature, we start reacting these ethene molecules with each other. So it's like ethene reacting with another ethene, and that is reacting with another ethene. So there are a lot of ethene molecules, and they are reacting with each other. And what's going to happen? So these one ethene molecules, when they start reacting with other molecules, they're going to form a long chain polymer. Okay. Then what's going to happen? They're going to form a long chain polymer. And this is also something that we call addition polymerization. So if I were to write a reaction equation for this, so this is going to be ethene. Okay. And you need high temperature and pressure. And you also need a catalyst, by the way. Okay, you also need a catalyst. You don't need to know the names of these catalysts. Okay, and what it is going to form? It is going to form a polyethene. Now, ethene, these are smaller units. These are what? These are smaller units. Okay, and this is a long chain polymer. And polyethene, by the way, if you guys don't know, this is also the plastic. This is what the plastic is made up of. This is the plastic material. Okay, so this is a long chain polymer, right? And if I talk about, let's say, if I write it the other way around, if I write it this way, we have got a CH2 double bonded to a CH2. This is again an ethene molecule. Okay, and the same condition, high temperature, pressure, catalyst. What's going to happen? This looks something like this. CH2 single bonded to a CH2. And don't worry, I'm going to explain this. And you can place an N. This N here means that there are a lot of ethene molecules present. Okay, there are a lot of ethene molecules present. Now, I'll explain this. So, let's say you've got this. This is an H in an H, double bonded to a C in an H. Now, this is an ethene molecule, right? This is an ethene molecule We place them under high temperature and pressure and under a catalyst. And what's going to happen? Now it's going to make this stuff. It's going to make this. Okay. This is what happens. You see, and this change is going to continue. So at this side, you're going to have one more C, which would be like this, and then one more C that would be like this, and here you have one more C that would be like this, and one more C and this chain keeps on going. Right? You get the idea? Here you had one smaller unit, and what happens when it undergoes addition polymerization, the double bond breaks, and all of these ethene molecules start combining with each other, start having single bonds, and it forms a very long chain carbon molecule. Okay, very long chain polymer actually. Okay, so this is how the chain actually looks like. And at most time, they won't ask you to draw a chain. What they would ask you is to write 2 repeat units. So from here to here, these are basically 2 repeat units for polyethylene. Okay, 2 repeat units. And it can also be a bit different. So let's say you say, what if we take any other molecule other than ethene? Because we talked about ethene, right? So in addition polymerization, what if we take any other molecule other than ethene? So you can also take, what's the next one? Propane. So what's going to happen if we take propane? Now it's not going to make polyethylene. It's going to follow the same structure, same reaction, same addition polymerization, but the product is going to be different. It's going to be polypropene. That is used in ropes and crates stuff. Okay, so with every ethene molecule, so with every alkene molecule, the product is going to be different. The reaction is going to stay the same. Okay, I hope this thing is clear. And this is where the reactions end. So we now have cracking and one or more smaller topics left for alkenes.